I need to let them in so that they can hear me. That's kind of important too. There we go. All right, good morning. Happy Monday after the Super Bowl. Everyone at home doing okay? Faith, can you hear me?
Yep. Yeah.
Okay, thank you. So we're going to go over questions 16 and 18 from the homework. Good morning, Mr. Rebar. And then we're going to look at continuing to combine functions together. So Friday we added, subtracted, multiplied, divided functions. So we're going to look at another type of way, I guess, that you could combine functions together. And that's called a composition function. So not a composition that you would maybe make or write in English class, but it's still a way to combine functions together. And it's like substitution. So we will be using this method to combine functions together and then trying to evaluate them and find their domains. So a lot of the chapter 6, as we continue through chapter 6, is working with functions and trying to manipulate them in certain ways, but also still working on those exponents and the power functions. The homework tonight, I'll pull this back up later. We should have time to kind of start some of the homework in class. It's kind of a mix of problems. This is a pretty big list, so maybe make sure that you rely on the assignment. The actual assignment has the problems listed as well, but it's not all of it. I kind of chose a few of them and crossed off some other ones. So we will look at that in a little bit. But if you want to take out your homework, we're going to look at 16 and 18, those two even problems from the homework assignment, dealing with the functions f of x, which was 4x to the 2/3, and g of x is 5x to the 1/2. And 16 and 18 were the division. I think this whole group of problems, the last group, 16 to 19, I think were the division problems. So it wants us to divide, in this case, f of x by g of x. So if we want to divide, you physically want to replace f of x and g of x with the functions they represent. So f of x is 4x to the 2/3. And then we're dividing that by g of x, which is 5x to the 1/2. So when you divide, you have to do the numbers in front, those coefficients, and then you have to look at the x's. Riley, what do you do with the x's when you're dividing and those exponents? So how do we combine those exponents together? It's all right. It's a Monday morning. Put you on the spot. Add, subtract, multiply, divide. What do you think you do with them when the problem is dividing? What do you do with the exponents to combine them together? Yeah, you subtract them. So the numbers in front, 4/5. You would reduce those if possible, but we cannot reduce 4/5. So we're not going to do anything with the 4/5. But we do have to subtract the exponents. So if I'm combining them, I have to subtract 2/3 minus 1/2. So when dividing and the base is the same, you subtract the exponents. Well, these exponents do not have a common denominator. We have to get them to have a common denominator. And if I look, I have a 2 and a 3 on the bottom, actually a 3 and a 2 on the bottom. So a 6 would be a great common denominator. If I make this one a 6, I'm multiplying it by 2. That means I have to multiply the top by 2 to make it a 4. And then the other one, if I make it a 6, I'm multiplying it by 3. And then the top I'm multiplying by 3 as well. So when I subtract those x's, I end up with x to the 1/6. Well, that x goes with the 4. Because the larger power was with the 4. 2/3 is bigger than 1/2, and I can see 4/6 is bigger than 3/6. So this becomes 4x to the 1/6 over 5. So the x's combine together by subtracting their exponents. Wherever the larger power is located is where the variable remains. So 4x to the 1/6 over 5. Any questions with number 16? So number 18 says f of x divided by f of x, and we're going to do it the exact same way. So f of x is 4x to the 2/3. We're dividing that by f of x again, so the same exact function. Zach, what happens when you take 4x to the 2/3 and divide it by 4x to the 2/3? Why do you get 1? Yeah. So the x's, if you take 2/3 minus 2/3, that's x to the 0. Well, x to the 0 is 1 as well. They cancel. Anything that's the same in a fraction cancels. So if I had x divided by x, that makes 1. X to the 2/3 divided by x to the 2/3 cancel, and they make 1. It's not 0. So it's not nothing, but they do make the value of 1. So when you're dividing, if you have something that's the same on the top and the bottom, it just divides and reduces and makes the value of 1. 19 was the same problem, except it's a g of x divided by g of x. Any questions from the homework? Any other questions from the homework? The last group of problems that I threw in there were just solving a linear equation for x, just to kind of review getting x by itself. Again, we're working toward that. Like we will be working toward trying to solve equations for x in this chapter. But our x's are going to have exponents. So we are getting to that point. We're just kind of building up to it. So we are going to go in the packet. This is still section 6.3. So it looks like it's page 29. And at the top of page 29, when you find that note packet that you have, we are looking at composition of functions. So that's what it's called. So this section kind of deals with, if you have two functions, how can you combine them together? So we can combine them together by adding, subtracting, multiplying, or dividing. Those are operations on functions. And now we're going to try and combine them together using this composition of functions. So again, this is page 29 in your packet. So composition of functions is another way to combine two functions together without adding, subtracting, multiplying, or dividing. Compositions of functions looks a little weird, and I'm going to show you how you will see that. You're going to see a function f, and then there's going to be parentheses. And inside those parentheses is going to be the g of x function. And then I will have a parenthesis on the outside as well. So I have two functions that we're combining together. One function is literally inside of the other function, which we will use substitution to help us combine these functions together. So we'll be substituting the inside function for the outside function. Now this is weird. There is a way to read this. I would say f, because that's the outside function. And then the parentheses is actually the word of. And then g, because that's the inside function. And then I have another parenthesis, so I'd say of. And then the x is the inside variable. So when you look at these f with parentheses, g of x with parentheses, we say f of g of x. That's called a composite or a composition of functions. So f of g of x, whatever's outside, and then you're just working your way till you get into the middle of x. Now we're still going to talk about the domain. So the domain is the overlap of the g of x, which is the inside function. So the overlap of g of x, the inside function, and the entire composite function together. Which is the answer. So we're looking at the overlap of the inside function with the answer, pretty much, the composite function or the answer. So we'll look at what was in the middle and what's the answer and what's the overlap of that. So this is a continuation from yesterday. That's why it starts with example 3. And we're going to work through some of these together. I will tell you that at first it'll seem a little different, but as you practice a couple, you'll get the hang of how we're using really substitution, one function into the other function. So we still have two functions, f of x equals 2x minus 7, and g of x equals x squared plus 4. We are trying to find the value. So when you're finding a value, you're actually finding a number. And we are trying to find g of f of 3. And I'm going to write that again. So g of f of 3. So when you work with parentheses, PEMDAS says you're supposed to do whatever is inside the parentheses first. And that applies to the function notation that we have here as well. So we are going to go inside the parentheses and evaluate, because it says what is the value. So we're trying to find a numerical answer. We're going to evaluate that inside parenthesis. So that's where I'm starting. And inside it says f of 3. We did this last week when we were looking at domain and range. Jaden, do you remember what we did last week to evaluate the function when it says f of 3?
So would you plug 3 into the x spot and solve?
Yeah, exactly. So we're going to take the 3 on the inside, plug it into the x of the f function. So my function f says 2x minus 7. Well, that x becomes 3. And then when I evaluate, I get 6 minus 7, which is a negative 1. So working inside the parentheses, we're starting with f of 3, and we're finding that number, finding the value. I'm going to go back now. This f of 3, we now know is the number negative 1. I'm going to replace it with the value I just found. So we found f of 3 to be negative 1. Substitution says if you find a value, you're allowed to replace it with that equivalent value. So now I'm left with g of negative 1. If I do the same exact thing, but take the g function and replace x with negative 1, then I've evaluated both functions in the problem. So it's like we're doing substitution twice. You're finding the inside number, and then you're applying that to the remaining function. So in this case, be careful with negative 1 squared. Negative 1 squared is a positive 1. I get the value of 2. So g of f of 3 equals 2. This would be my final answer. So it's really a 2-step problem. Jordan.
Miss Kane, that 1 should be a 4.
Oh, it should be a 4. Yep. Yep. Thanks. I don't know how I saw 1. Thank you. Thank you. Should be a 5 there. So my final answer is g of f of 3 equals 5. X squared plus 4, not x squared plus 1. Any questions on that? So you're doing inside, you're taking that answer, you're applying it to the remaining function. So it's like you're doing it twice because they're 2 functions. So the second type of problem doesn't have a number inside, and instead there's just an x. So that means I'm not going to find a value as an answer. My answer is going to have an x remaining in it. But we're going to solve it the same way. So we're going to start in the middle of the parentheses, and in the middle is g of x. So we're going to take out g of x and replace it with whatever it's equal to. So Zach, what is the g of x function equal to? Look at the g of x function. So what's the g of x? Yeah, 5x minus 2. So here's my g of x function. It's equal to 5x minus 2. So we're going to take out g of x and replace it with 5x minus 2, which is exactly what we kind of did above, but I had a number to replace. I don't have a number this time. All right, here's the part where it gets a little weird. Now it says f of 5x minus 2. Instead of having a number there, I have this whole expression. This expression represents x because it's supposed to be f of x. So all of this is x, the whole quantity. We are going to go to the f function, which says 4x to the negative 1. And instead of replacing x with a number, we're replacing it with all of the expression 5x minus 2. So it is substitution. You're substituting x with this entire equation or expression 5x minus 2. Questions with that step? Now, there is one thing that we have to do to this because there is a negative exponent. This part here is all raised to the negative 1. And Zach was trying to do this actually with the f of x function originally. The part that's raised to the negative 1 needs to move underneath to the denominator of the fraction because it has to have a negative exponent. So we still have the 4, but under the 4 is now 5x minus 2. Because it was raised to the exponent of negative 1, and we have to make that exponent positive. So you can't leave a negative exponent in your fraction or in your equation. This is your final answer. So f of g of x is equal to 4 over 5x minus 2. And if you look at the original 2 equations, you can see that it really is a combination of both of those equations put together. Questions?
Can you simplify it?
That's a good question. So the only time you can simplify it is if you can divide everything by the same number. So that means I would have to be able to divide 4, 5, and 2 by the same number. So if that 5 set a 6, then I could divide all of them by 2. but the 5 cannot be reduced. So with a fraction, what you do to one thing, you have to be able to do to every single term in the fraction. Does that make sense?
Yeah.
Okay, good question though. So when it comes to fractions, students want to like over simplify fractions, and they actually, in most cases, fractions can't be simplified, which seems weird to keep it like this, but it is the answer, the simplified answer. So we are going to find the domain. And when you look at this, it is a fraction. So thinking about the domain, when you have a fraction, the domain cannot equal 0 when you have a fraction. The denominator can't be 0. So in this case, that means x cannot be, if I solve for that, take the 2 to the other side. X cannot be 2/5. So my domain is negative infinity to 2/5, and then 2/5 to positive infinity. That would be the domain of the function. So anytime it's a fraction, that's when we have to look at the domain. Or when it's a square root, we have to look at the domain. Questions? So we're going to try the next one, which pretty much asks us to do the opposite. So part B in the middle here says take g of f of x. So we're going to start with the inside, always with the inside. So look at that inside function. It's f of x. My function for g, that stays outside, f of x is 4x to the negative 1. So I'm taking my inside function and plugging it in parentheses. Now we're going to the g function, which says 5 times x minus 2. And this, whatever's in parentheses, replaces x. So 4x to the negative 1. Questions so far? So this can be simplified because 1, I have parentheses, 2, I have an exponent. So we can simplify this. The first thing that I can do to simplify is to multiply the coefficients together because I have a 5 times a 4. So I can multiply those and get 20. They're just coefficients. They're numbers in front. And then I have x to the negative 1 minus 2. So now I can multiply 4 times 5 because they're coefficients. I have the x to the negative 1, and then we have the minus 2. The next part we can do to simplify is this x to the negative 1. That's a negative exponent. That has to go into the denominator. In front of it is 20. So that 20 stays in the numerator and the x goes to the denominator. And then we have minus 2. This is as far as you can go. You don't need to simplify it any further. 20 over x and then minus 2. Questions? So again, it says, what is the, yes, question?
Why didn't you put 10 minus 2 over x? Like, I don't understand why you didn't put x all the way up there.
X, oh, say it again.
So like, I don't, like, it wasn't 20 minus 2 over x, it was 20 over x minus 2.
Correct. So this minus 2 is not connected with the x. It's separate. It's by itself. I'll erase it and make it separate. It doesn't have an x next to it, so it has to stay separate. The x is connected with the 20 and only goes with the 20. It doesn't go with the minus 2.
Okay.
So the minus 2 doesn't have an x next to it. That x isn't attached to it. It is a separate piece. So I cannot combine those together because they are not like terms. They're two separate numbers. Does that kind of make sense, Brooke?
Yeah.
Okay. Brooke, can you tell me what the domain is? There's that fraction. The fraction can't be 0.
Negative infinity, 0, and then 0, positive infinity.
Excellent. Nice job, Brooke. Good. Good questions. There's one more right next to it with these same two functions. So let's look at part C. And we're going to see if we can do this the same exact way. Part C, though, says f of x. So again, start in the middle. The middle is f of x. So I have f on the outside. In the inside, I'm replacing that with 4x to the negative 1. My f function is 4x to the negative 1. So I have 4x to the negative 1. This 4x to the negative 1 needs to replace x. So it's substitution. You're replacing x with whatever's in the middle of the parentheses. In this case, that f of x gets plugged into f of x. So I'm taking the same function and plugging it into itself. And again, if you look, you can see that you have that same function. I have 4x to the negative 1. So now I need to apply those exponent properties. So thinking back to chapters 5 and the chapter that we're looking at, this exponent of negative 1 has to get applied to both the 4 and the negative 1. So both 4 and the negative 1, it gets applied as an exponent. The 4 on the outside isn't changing because it's on the outside. It's not affected with the parentheses. So I would have 4 to the negative 1. And then that x to the negative 1, multiplying it by negative 1 becomes a positive 1. So again, let me go over that one more time. We replaced x with 4x to the negative 1. But that x was raised to the negative 1 power. That negative 1 power distributes as an exponent to both the 4 and the x, which already had a negative 1. And we multiply those exponents together. So if I still look at the inside, just the inside, because that's what's grouped together. The x has a positive exponent, but the 4 has a negative exponent. The 4 needs to move. So whatever has a negative exponent has to move to the denominator, not the other part, because the other part, the x, has a positive exponent. They do separate from one another. And there's still a 4 in front. Faith, when there's a 4 in front, what operation are we doing with the 4 and then parentheses x over 4?
Multiplication.
Yeah, you're doing multiplication. So that's really like having a 4 over 1 times an x over 4. So Faith, what would that become if I multiply 4 over 1 times x over 4?
4x over 4.
And then what is 4x over 4?
Just x.
Just X. Yeah, just X. Nice job. Any questions? What's the domain of just X? Anybody know? Anybody at home? What's the domain of just X?
Is
Jordan,
it
you-
negative infinity to positive infinity? Sorry.
Yeah, nice job, Jaden. Nice job. Questions? So they're a little tricky. Take it one step at a time. The last three problems down here are evaluating problems. So you're going to find a number answer if there's a number inside. You're going to have an answer with X if there's an X inside. So it just depends what's in the parentheses and how your answer will look. So this last example, it says, find the following. We have G of F of 5. But you always start in the middle, like PEMDAS, parentheses, always beginning in the middle of the problem. So we're going to start in the middle and find F of 5. In the previous three problems, it had an X, so we just replaced that whole thing with the equation. But now we're going to actually find a number. So these are a little nicer when we're trying to find the number. So 3 times X minus 8, and X is 5. Riley, what is 15 minus 8? 7. So I take that 7, I replace it in for F of 5 because I just found the number to be 7. And now I have 2 times X squared, and it's 7 squared. So Riley, 7 squared is, and 49 multiplied by 2 becomes, I'll help you out, 98. So these are like a little easier, I think, because you're plugging a number in and you get a number answer. Let's look at B, G of F of 5. So start in the middle. We have to start with G of 5. So 2x squared. And we're plugging in 5. So square 5, order of operations, got to do exponents before multiplication or division. And I get 50. So now that 50 replaces G of 5. So my F function says 3 times X minus 8. X is 50. So Madison, the 3 times 50 minus 8, what does that give us?
Sorry, let me grab my calculator really fast.
Well, let's start. What's 3 times 50? You can do that without a calculator. On a Monday morning.
150.
Yeah, what's 150 minus 8?
142.
There you go. See, you didn't need a calculator. So F of G of 5 is 142. And then one last problem. This one wants us to do F of 5. So start on the inside. So 3 times 5 minus 8. We already said that was 7. So you're taking that 7, you're replacing it in for F. And now we're doing 3 times 7 minus 8. So 21 minus 8 would be F of 5. Zach, 21 minus 8 is? Say it again. Yeah, that's what I thought you said. Any questions on those problems? All right, so we're going to travel over to Google Classroom, and we are going to see if we can start or at least look at this homework. Start it together. So this is really substitution. That's essentially what we are doing. Wrong class. You're substituting one function in place of the other. Instead of adding, subtracting, multiplying, dividing, we're substituting functions. All right, so if you refresh your screen, it should be up there for you. As I said, in the instructions, I have the problems written, typed in for you. So we're looking at 1 through 12, 15, 16, 17, 23, 24, 25 to 29, which we will go to that worksheet and we'll circle them as well, or at least write it on the top. So I'm going to pull up my worksheet as well. Your worksheet, I think, looks better than mine. I need to find my other copy. I have it in there. Just need to find it. So again, we're doing 1 through 12. 14, 15, 16, 17. I guess I could have said 14 through 17 there. 23 and 24. And then those last group of problems is like a set of word problems. They're all together. It's one big word problem, 25 to 29 with multiple parts. So 1 through 12 would be what you did on Friday. Let's look at number 14. And let's work through number 14 together. So 1 through 12 is combining functions with operations, adding, subtracting, multiplying, dividing. And then I'm asking you to do 14, 15, 16, and 17, so we don't have to do the other problems. And then in the last group, you're only doing those last two problems with the composition of functions. So let's look at 14. Let's kind of go through this problem. Perform the indicated operation. So it doesn't say state the domain in this group, but the next group says state the domain. So we don't have to worry about the domain here. There are 3 functions given. Make sure you're choosing the correct functions. So it says g of h of x. So inside is h of x. H of x says x plus 5 divided by 2. Now I'm going to go into the g function and replace x. So this is going to look a little weird. So it says 3 over x plus 1. Well, x is x plus 5 over 2. So it still says 3 over x plus 1, but that x has changed. Now, this one's a little tricky because in this denominator, we have these 2 fractions. The first fraction has a denominator of a 2. The second fraction is just, actually, it's just a number 1. But I know that I can write that number 1 as 1 over 1. And if this has a common denominator of a 2, what does 1 over 1 become with a common denominator of a 2, Jordan? 2 over 2. So there's a 3 on top. And now on the bottom, we are going to add across. And this is a little tricky. So we're adding x plus 5 plus 2. Ah, the bell rang. This becomes x plus 7 and then over 2. So again, try and do the problems. You don't have to do all of them. Do the ones that I've listed at the top. We'll probably talk about a couple of these tomorrow. Have a fantastic day.